Medic 195.
10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0.
This is your captain speaking.
Copy that, you're 2 clicks south on the LZ.
Medic 195.
Medic 5.
You can start for Southport.
10-4.
I started working in JQuat in 2019. Immediately after, I realized the potential of the students. There are many interesting projects, final year projects, research going on. I also realized there is interesting history in Kenya. It has an interesting, unique history of the space development. In the past, they have launched satellites, Italian satellites from the coastal region. In 2018, University of Nairobi team has successfully developed CubeSat and launched it. However, there are no rockets yet. So why don't we start a project to build a rocket with the students and make the first rocket in Kenya that can bring the nanosatellites into the space. We had a kickoff meeting with the 20 students. And in the meeting, I told the students, it's very important to name this project. I didn't have any request except one. We want to have some name which reflects Kenya or Africa. And one student proposed this name, Nakuja. And they said it means I'm coming. We are coming to the space. In Nakuja project, we are making a rocket. This is student-oriented activities. Many students are so excited. They are separated into each expert group, avionics, airframe, propulsion, and working together for the common goal, which is to launch the rocket. And we are spearheading space development in Kenya.
My inception with Nakuja was actually during one of the student engineering programs where Dr. Aoki was actually making a presentation for Nakuja, and it was very awe-inspiring. So I decided, let me follow him and ask him about it. And I spoke to him, and he actually referred me to another one of the students called Washington, who was part of the MVP, the initial team, and I ended up joining the avionics team. And from there, it became everything that I was for the remaining 3 years of my university life.
K-Fire is the rocket that should get us into space. It's a liquid-propelled rocket engine. Liquid-propelled rocket engines are very good engines. They can be controlled. They give us a high specific impulse. However, they are very complex systems. It is a gradual process where we have to understand the type of materials that we need to work with, how to work with the fuels, and how to control the fuels, how to control the ignition, how to build the combustion chamber, and how to integrate all these into the major rocket. The process of getting to space is gradual. So our first target was 500 meters, then a kilometer, 1.6 kilometers. We are now aiming at 3 kilometers, moving on to 10. And after we achieve 10, we should be able to go beyond and get into space.
Nobody believed that we can make the rocket. So we just decided to study the literature and made a first prototype. And it worked. Although it was very small, almost like a fireworks, but it worked.
The students have surprised us in many ways. To start with, when this project started, we did not have aerospace engineering as a program at the university. And the students who were initially invited by Dr. Aoki were students from mechatronics, electrical engineering, mechanical engineering, with different backgrounds. None of them actually knew anything about rocketry. But just from the fact that they were told they're going to build a rocket, I think they got excited about it. And with that background, these students have actually been able to put together a rocket that can fly. We've been able to achieve 1.6 kilometers, which is a great achievement. And we are just building on that knowledge to get to where we want to be at.
KSA in Nakuja, we see Kenya being a launch state. Nakuja Project has become international because we are working on collaboration framework with other potential rocket manufacturers outside Kenya. This goes by noting the ongoing engagement with the University of KwaZulu-Natal on a rocket project. And at the same time, we are looking forward towards being able to showcase our capability in the Space Cup America, which means we are going international.
I think what really caught me going was the design, make, and launch. Those three words, and that was it for me.
To a student who's interested in getting into the Nakuja project, do it. It will cost you sleepless nights. It will cost you very early mornings, days where you doubt yourself. But at the end of the day, when you build something and you see it and you see that, oh, it has launched, or oh, we're actively getting communication, or oh, our computing systems are working, it is worth the while.